The ocean is the greatest carbon vault on the planet. And this ability of the ocean to permanently store CO2 doesn't only rely on the immense size of the ocean, but on the natural alkalinity of seawater. Over millions of years, minerals from weathered rock have washed into the ocean, boosting the alkalinity and allowing the ocean to safely store CO2 and balance the climate over millions of years. And ocean alkalinity enhancement enhances this natural process.
We've known for a long time that if surface alkalinity in the ocean increases, this affects carbonate chemistry in the ocean, which then has an influence on air-sea gas exchange. So when alkalinity increases, pH also increases. This eventually moves CO2 into another form, which lowers the PCO2 of seawater so that the ocean can take up more carbon and store it.
Carbon dioxide removal is not a substitute for steep emissions cuts, but it's now required for meeting global and national net zero carbon dioxide emissions targets. So it's an important tool for mitigating the worst climate impacts, and we need to understand all of the tools that we have.
Our approach is simple. As the largest funder in this space, we are supporting the world's best scientists to test ocean alkalinity enhancement's viability as a climate solution focused on safety, effectiveness, and measurability. And as a trusted field builder in this space, we're bringing together the key players from government, academia, and industry for a responsible path forward. And in the last couple of years, we have spent and committed more than $40 million to do this in the most responsible manner possible.
Public-private funding partnerships for marine carbon dioxide removal research are already helping create a vibrant research community. NOAA has a cooperative research agreement with Carbon to Sea to develop data management practices for marine carbon dioxide removal, and those will be applied across future research efforts. The public-private partnership here will facilitate the development of these guidelines that can be shared across the sector to really support marine carbon dioxide removal research broadly.
We know that philanthropy can't do it alone, but all across the globe, we're seeing governments really step up and supporting academic researchers and private sector companies. In the United States recently, we saw really positive bipartisan support for evaluating ocean alkalinity enhancement as a potential solution.
The field of MCDR presents a unique opportunity not only because of its immense potential benefits, but also because it builds off existing knowledge and research for land-based carbon removal that is already delivering results.
In Halifax, we are university researchers, myself included. We're collaborating with a startup company that's located here, Planetary Technologies, on OEE field trials. Planetary has a permit and a collaboration with the local power plant, using the cooling outfall of the power plant to dispense alkaline feedstock, so basically ground up brucite rock powder, into Halifax Harbor. And we are making a bunch of measurements and also developing models, predictive models of the water movement and chemistry and carbon uptake.
The field of ocean alkalinity enhancement is really new, and field research is just starting. And as it starts, at Carbon to Sea, we are playing an important role in setting the best practices for community engagement that ensure that there is a transparent and accountable process for the engagement of the key resource users, as well as process by which communities learn transparently what is being learned by researchers in real time.
If you want to become partners with First Nations, it's very important to get in very early on. We were invited to submit a proposal for the joint learning opportunities for the ocean alkalinity enhancement. And with that, we've had a long-term good relationship with the key partners, Planetary Technology and Carbon to Sea.
We still have some fundamental work to do on the basics of ocean alkaline enhancement. We still have to answer the questions, is it safe to do ocean alkaline enhancement? Does it remove CO2 from the atmosphere and store it permanently? There's also work going on to figure out which are the best feedstocks for ocean alkalinity enhancement. So these are all things that people are focusing on now.
The fact is, we're going to need a lot of different people from a range of disciplines in order to ask and answer all of these questions. But what we see right now in the field is all of these folks coming together in a way that is pretty exciting and exactly what it's going to take to get to the bottom of this.
What sets Carbon to Sea apart? We have no financial stake in any solution. We are pathway agnostic and open to all outcomes, even if our research ultimately shows that ocean alkalinity enhancement is not viable as a climate solution. Success for us means to help the world understand what the best solutions for the climate may be and do so quickly and responsibly.